Some more examples to look at. Look at this particular one. Very similar to the last one, but again, slightly different. This table shows the cost of student bus tickets, C, in dollars. So now we're not using X's and Y's. We're actually using other variables. C represents the cost in dollars. We're also saying the number of tickets now are N here. Bada boom. So N represents the number of tickets, C represents the cost. And to think about it, how many tickets are you going to buy? Well, I can buy 5 tickets. I can buy 15 tickets. I can buy 1,000 tickets. Well, that makes them independent. I'm deciding how many tickets I'm going to buy. And what's the result? This cost depends, again, upon how many tickets you buy. So that's your range. There's your domain. There's your independent. There's your dependent, which, of course, this tells you that this is going to be on the x-axis. This is going to be on the y-axis. But wait, hold a second. We don't have an x-axis or a y-axis. Well, yeah, technically, we can still call them x and y, but when we put them down on the graph, let's refer to them as they're supposed to be referred to, the n and c, the independent and the dependent variables. Okay, so here's my relationship. Obviously, the bus tickets are $1.75 each. If you buy 2, you're $3.50, and so on, and so on, and so on. So here comes my graph right over here, and let's put it on there. So our dependent variable, of course, goes on the bottom. This is N. This is our number of tickets. Okay? Our dependent variable is C here, and this, of course, is our cost in dollars. Okay? So, perfect. Let's go. Let's put them down. Again, I'm going to skip 1, 2, 3, 4, 5. Notice that I always like a graph that just covers the entire area of the graph. Make them nice and big. Don't make your graph look some little small little thing in the corner as like, ugh, that's garbage. You got graph paper? Fill it. Now, notice the increments. I'm going to go by $1.75 increments. Again, I'm going to make this nice and uniform. There's $3. Over here, there's your, or sorry, $3.50. There's your $5.25, which is going to go here. Going to skip 2 and go, this is my $7. And of course, they don't always work out beautifully like this. In this case, it works out, oh, $8.75. My apologies. In this case, everything kind of works out kind of nice. Sometimes these numbers may have slight variations. Don't go up by what these numbers go by. Try to find the difference that they go up by. So that would be your amount of increments. We'll do one like that eventually. You'll see. So again, if you buy 0 tickets, it's 0. If you buy 1 ticket, it's $1.75. If you buy 2 tickets, it's $3.50. 3 tickets would be $5.25. 4 tickets would be your $7, and 5 tickets would be your $8.75. Again, ask yourself a question. Should we connect the dots? Well, what does a connected dot mean? A connected dot would mean that you could buy a half a ticket. Well, go ahead and try to buy a half a ticket. It ain't going to happen. Half a ticket means you ripped your ticket in half and it's worthless. So these values in between have no value, no meaning, right? So, of course, this then, again, is called discrete data, okay? And that's how you do this question. So let's keep on going then, and let's look at another example. Most of these examples so far have given you a table of values. I've given you all the information. Not anymore, okay? In this particular question, it's all words. You have to figure it out. It says, another popular event at, I can't speak French, so there we go, is the fireworks display. Assume that an event organizer sends off, here we go, 20 fireworks every minute. So think about this. We're setting off 20 fireworks every single minute. Then we've got a bunch of questions to ask ourselves here. So before I do any of these questions, let's just think about this for a second. We have a dependent variable, and we have, an independent variable. There we go, independent, and we have a dependent variable. What would be the independent variable? if you think about this, what would be the independent variable? You're setting off a number of fireworks per minute. The number of fireworks, which is up here, says 20. You're sending off 20 fireworks every minute. Okay, so question. At 0 minutes, how many fireworks went off? Well, 0. After 1 minute, you got 20 fireworks. After 2 minutes, you have 40 fireworks. After 3 minutes, you've got 60 fireworks. In other words, you're going up by 20 fireworks per minute. Now, I got a simple question for you here. Now, think about this again. Does this mean for 0 to 1 minute, there's no fireworks, and right at 1 minute, boom, all 20 go off? Well, I hope not. That would be a pretty boring display. So what happens is over the course of the entire minute, there'd be like, 20 fireworks. You're looking at several fireworks off every second or so. Every 2-3 seconds, there should be another firework going off. Boom, 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 boom. And it's going and going. So I got a question for you. Is this going to be discrete or continuous data? Well, in a sense, if you start splitting hairs and go down to milliseconds, it would be discrete data. But the fact that over the course of 1 minute, you've got 20 fireworks going off, I would say that this is continuous. I would say this is continuous data. Why not? Okay, so let's draw ourselves a nice little graph here. And you know what? by doing all of this, I've probably answered half the questions already. This is going to be time. Okay, let's have this in minutes. Let's call this T. This is our dependent, which we'll call it fireworks. Okay, so I'm just going to call it F for fireworks. This is our dependent one. And we're going to say that this is in terms of a number of fireworks. Okay? All right, here we go. So there's our graph. Time would go down here in minutes because it is our independent, and the independent always goes on the bottom. Up here would be our fireworks, okay, which we'll call F, and that's, of course, in terms of a number of fireworks that are going off. Okay, perfect. Let's graph this. Here we go. 0, 0, 120, 240, 360, and so on. And so you'll get the points here again, but like I said, look how many independent points you can have in between. You don't say 0 minutes and then right at 1 minute, all of them explode. No, they explode throughout the course of that minute. And they explode throughout the course of the second minute, through the third minute, through the fourth minute, and so on until the show is over. See what I mean? So this, in fact, you can actually draw a line for this representing continuous data. Now that I've done all of that, it was kind of silly. I did the question first. Let's go back and answer, or I should say I did the graph first. Let's go back and answer the question now, which is like, huh? Usually you answer the question as you go. Well, some things you couldn't necessarily answer until you saw the data and you saw the relationship as a graph. So the question says, is the relationship between the total number of fireworks and the duration of the event linear or nonlinear? In other words, is it a line? Well, yes, it is. How do I know? Because it's the same amount of fireworks being blown up every single minute. So it says assign a variable to represent that. We did. We said time, T, and F for fireworks. We're good. Which is dependent, which is independent. T, of course, our time. You're choosing when to calculate this. I'm saying every minute. I could have gone every 30 seconds. I could have gone every 10 seconds. I could have said after every 10 minutes. You're deciding the time intervals. So that's what makes this the independent. And the dependent, what do you get out of this? If I'm saying every minute, oh, okay, then it's 20 fireworks a minute. See how it works? Okay, create a table of values. We did. Create a graph. And is it discrete or continuous? In this particular case, unless you're splitting hairs, let's go with continuous. I think this is just a great example that sums it all up.